Section 3.2 Rolle's Theorem and Mean Value Theorem. Rolle's theorem and mean value theorems are another application of differentiation. First, in order for you to apply Rolle's theorem, three conditions has to be met. First, f is continuous on closed interval AB, and f has to be also differentiable inside that open interval A to B. Number three, the endpoint has to have the same function value. In other words, f of A has to be equal to f of B. If these three conditions are all met, then you can conclude that there has to be at least one number in the open interval A to B, such that f prime of C equals 0. So look at the example right below. You have a continuous function from 1 to 9, and f of 1 is 10, and f of 9 is 10. Let's see nothing happens, and even if this was a straight line, then slope would be 0 at every single point in the interval 1 to 9, right? So it's still true. But let's say f of 1 is 10 and f of 9 is 10, and now it is not a straight line, but it is continuous function. Then as you left this point, as this picture, it has to go down, but then at some point it needs to come back up. So in this case, you have a one point at x equals 4 where f prime of 4 is 0. But of course, this could happen multiple times, right? You could have this. Then you would have had multiple points where f prime is 0. So that's why it's saying at least one number C in that interval such that f prime is 0. Not only that, if you had a hill also, this would be also 0. But because the endpoint is equal, if it went down, it needs to come back up without lifting the pencil since it's continuous. Make sense? Even if it went up, let's say, then it needs to come back down to have a same function value at x equals 9. So then again, I would have some point C such that f prime of that value is equal to 0. So this is what the Rolle's theorem is saying, and make sure that you check all these three, and after you check all these three conditions, you can say then Rolle's theorem applies, and there is a C such that f prime of C is 0. So let's look at this problem. Find the value of C guaranteed by Rolle's theorem on the interval 1 to 9, or explain why it does not apply. You can say f is continuous on closed interval 1 to 9, and second, f is clearly differentiable on open interval 1 to 9. Number 3, f of 1 is 10, which is equal to f of 9. And because all these three conditions are met, Rolle's theorem applies. And where is that C? So that C was 4. So the C that they're talking about in Rolle's theorem is 4. Find the value of C guaranteed by Rolle's theorem on the interval 1 to 7, or explain why it does not apply. So let's check 3 steps of Rolle's theorem. First step, looking at the graph, is this function continuous on closed interval 1 to 7? Yes, it is. By graph given, f is continuous on closed interval 1 to 7. Now, looking at the graph, is this graph differentiable on open interval 1 to 7? No, right? We have a sharp turn here. So we know clearly this function is not differentiable at x equals 6. So, well, f prime of 6 does not exist. Why? There is a sharp turn. So f is not differentiable at x equals 6. And 6 is in that open interval 1 to 7, and thus Rolle's theorem does not apply. And you stop. Don't ever make any other conclusion. Find the value of C guaranteed by Rolle's theorem or explain why it does not apply. F of x equal x to the fourth minus 12x squared on the interval -4 to 4. Is this function continuous? This is a polynomial, so it is continuous on R, so it will be continuous on closed interval -4 to 4. So we say since f is continuous on all real numbers, it is continuous on closed interval -4 to 4. Step 2. Is f differentiable on open interval -4 to 4? Let's take the derivative. What's f prime of x? F prime of x is 4x cubed minus 24x, which is defined on all real numbers. So f is differentiable on open interval -4 to 4. And then we got another condition to check, right? What's f of -4? That's a -4 to the power 4 minus 12 times -4 squared, which is 256 minus 16 times 12 is 192, and 256 minus 192 is 64. And f of a positive 4 is 4 to the power 4 minus 12 times 4 squared, which is 256 minus 192. Oh, so they are the same. So all three conditions are met, and you can say, does Rolle's theorem apply? But what did the Rolle's theorem say? If these three conditions are met, then there exists A, C in the interval A to B, and in our case, our open interval A to B will be open interval -4 to 4, such that f prime of C equals 0. That's what Rolle's theorem said. So what's f prime of C? F prime of C is, take the derivative of this, and then you plug C in there, so that will be, what is it? You just take the derivative, but instead of x, you use letter C. So f prime of C then would be 4c to the third power minus 24c. And we set that equal to 0 since we want a C such that f prime of C is 0. So we need to factor it, so we can have a common factor 4c out, and that will give me c squared minus 6 equals 0. So c is 0, or c squared equals 6 means c equal plus minus square root of 6. But square root of 6 is about 2.4. And I need to find c in this interval. So is 0 good? Yes. Is square root of 6 good? 2.4, positive 2.4 is in that interval. What about negative 2.4? Oh, that's in that interval too. So I found the 3c values such that f prime of c is 0 in that interval. Find the value of c guaranteed by Rolle's theorem or explain why it does not apply. Well, this is square root function. Square root function has a domain problem. But as far as in the domain, this function will be continuous in the domain. So we first need to find the domain. Step 1, domain of square root function is input greater than equal to 0, because positive number cube is positive, negative number cube is negative. So as far as 4 minus x to the 2/3 power is positive, then its cube will be also greater than equal to 0. So domain will be any x such that 4 minus x to the 2/3 power greater than equal to 0. And that would mean that 4 is greater than equal to x to the 2/3 power. And you can cube both sides to get rid of the rational power, which means 64 then is greater than equal to x squared. If I write the other way, that means x squared is less than or equal to 64. That will mean that x squared minus 64 is less than or equal to 0. So as you know, this factor as x minus 8, x plus 8 less than or equal to 0. So that will give you negative 8 and 8, of course, is included since at that point it is equal to 0. So this inequality is true. But now you can find all your testing point to find out which interval it gives you. So if you plug negative 9 here and negative 9 here, that's a negative times negative, which is positive. And if you plug 0, which lives in between negative 8 and 8, if you plug 0 there and 0 there, I get negative times positive, which is negative. And if you plug any number bigger than 8, let's just say 10, 10, it's a positive times positive, so it is a positive. But I need the x such that when you multiply these two values, it is less than or equal to 0. So my domain will be right here, including ending points. So this function f is continuous on negative 8 to 8. So it is then continuous also on negative 1 to 1 since that's inside of there. Now I need to do step 2. Is this function differentiable on open interval negative 1 to 1? Let's actually find the derivative. So I'm going to rewrite my f of x to take the derivative. And this is 4 minus x to the 2/3 power to the 3 over 2 power. So my f prime of x then is, I need to use the chain rule, right? Because I have an inner function and I have an outer function. My outer function is a power function with a power 3 over 2. So take the derivative outside. I get 3 over 2 times 4 minus x to the 2/3 power to the lose 1 power. That's a minus 2 over 2. So I get 1/2 power times. Now I multiply by derivative of inner function. Derivative of 4 is 0. Derivative of negative x to the 2/3 power is negative 2/3 x to the, I lose 1 power from 2/3, so I get negative 1/3 power. Alright, so now if I clean this up, I have 3 over 2 times negative 2 over 3. So those needs to be canceled out, and then I'm gonna only get negative 1 there. Because 2 cancel, 3 cancel, I just get negative. And this is numerator, so I'm gonna put it back as a radical, 4 minus x to the 2/3 power. And then this guy is a negative exponent, so it needs to go to the denominator. And it will be x to the 1/3 power now in the denominator. But 1/3 power is cube root of x. So this is what my derivative looks like. Okay, and this derivative does not exist at x equals 0. F prime of 0 does not exist. F prime of 0 does not exist because denominator cannot be 0, right? So this function is not differentiable at x equals 0, but 0 is in the open interval negative 1 to 1. So I gotta quit now. Because of this second condition, Rolle's theorem does not apply. Now we have a general Rolle's theorem, which is called the mean value theorem. And mean value theorem is one of the most important theorem in calculus. So here is mean value theorem, and you can abbreviate that as MVT. And here is the condition for MVT. F is continuous on closed interval AB. Second condition, F is differentiable on open interval AB. So you notice that our third condition on Rolle's theorem disappeared. So f of A doesn't have to be equal to f of B on mean value theorem. And if they're equal, then it becomes Rolle's theorem. And it's just saying if you have a continuous function on a closed interval AB, and that function is differentiable on the same interval but it's open interval AB, then now there must be a number c in that open interval AB such that f prime of c equal f of b minus f of a over b minus a. And what is f of b minus f of a over b minus a? Isn't that quantity very familiar with you? Of course, this is the slope of a secant line, right? Fb minus f of a over b minus a. So this point is what? A comma f of a. This point is b comma f of b. What is it saying? If you have a continuous function on a closed interval a to b and differentiable function in open interval ab, then there has to be some point C in that interval such that slope of secant line connecting these 2 points is equal to the slope of tangent line at some point. There has to be point C in that open interval such that f prime of C is equal to the slope of secant line connecting a comma f of a, b comma f of b. And if you think about it, if FA and FB was equal, then this would have been 0 over B minus A, so it would have been 0. So just like if f of A is equal to f of B, then naturally this theorem becomes f prime of C equals 0. So this is a more general theorem of Rolle's theorem. But now we don't have to have this, but it's saying that there must exist a tangent line that is parallel to the secant line connecting the endpoints. In terms of rates of change, this MVT implies that there must be a point in the open interval AB such that instantaneous rate of change is equal to the average rate of change over the whole interval A to B. So this is what the MVT guarantees. So now let's look at this example. Explain why the MVT applies and indicate the value of C on the graph. Step 1. By graph, f is continuous on closed interval 2 to 14. Step 2. By graph, f is differentiable on open interval AB, which is open interval 2 to 14. What do you mean by graph? Well, there is no sharp turns, no holes, no jumps, or no vertical asymptotes. So f is differentiable on open interval 2 to 14. So thus, by mean value theorem, there exists C in the open interval 2 to 14 such that f prime of C equal f of 14 minus f of 2 over 14 minus 2. And we see that this is 2 comma 3. And this is a 14 comma 6. So f of 14 is 6. Subtract f of 2 is 3. Over 14 minus 2 is 12, which is equal to 3 over 12, which is equal to 1/4. Yeah, something's wrong with this problem. We can explain why MVT applies, which we did, and we cannot find the value C here because we don't have actual function that we can find the derivative and plug C in there. We know there exists C, and we can find out what f prime of C value is. So let me rephrase the problem. Just say find f prime of C. And f prime of C should be value 1/4. So this is how much you can do. We know MVT applies. We know there exists C such that f prime of C is equal to 1/4. Next problem. Here, we will be able to find the value of C because fx is there. So we will be able to find f prime of x. So therefore, we can get the f prime of C equal f of b minus f of a over b minus a. We set it equal to that value, and we solve equation. and we will be able to find such a C. So let's actually do this. Determine if MVT applies and find all values of C, or explain why it does not apply if it doesn't apply. So this is a rational function, and like I said before, rational functions are continuous in their domain. And domain of this function is all real number except 0. I am given an interval from 1/2 to 2, which does not include the 0 there. So this function is continuous on a closed interval 1/2 to 2. So let's start. First, fx is continuous on all real number except 0. So it is continuous on closed interval 1/2 to 2. Secondly, let's find the f prime of x. F prime of x equal, let's use quotient rule. Low d high minus high d low over square below. So then that is x. Let's distribute the negative. I got negative x minus 1 over x squared, which is equal to negative 1 over x squared. And f prime exists on all real numbers except 0 again, as you see. So f is differentiable on open interval 1/2 to 2. Thus, MVT applies, and there exists a C in the open interval 1/2 to 2, such that f prime of C is going to be equal to the slope of a secant line connecting 1/2 comma f of 1/2 and 2 comma f of 2. So that will be f of 2 minus f of 1/2 over 2 minus 1/2. And what is f of 2? Let's calculate on the side. F of 2 is 2 plus 1 over 2. So that's a 3/2. And f of 1/2 is 1/2 plus 1 over 1/2. So let's just multiply everybody by 2. So then it is 2, 2 cancel, 2, 2 cancel, 1 plus 2 over 1. So it is just 3. F of 1/2 is 3. So let's keep going. So f prime of C is equal to f of 2, which is 3 over 2, subtract f of 1/2, 3 over 2 subtract 1/2. Again, let's get rid of all the denominators by multiplying everybody by LCD, and LCD is 2. So again, times 2, this cancel, times 2, it becomes 3 minus 6. 2 times 2 is 4. When you multiply it 1/2 times 2, 2, 2 cancel, you get 1. So you get negative 3 over 3, which is equal to negative 1. So then now, f prime of C, remember we found the f prime of x right here. Yeah. So what's f prime of C then? F prime of C is equal to negative 1 over C squared. And we are saying that's going to be equal to the f2 minus f of 1/2 over 2 minus 1/2, which simplifies to negative 1. So you can cross multiply and set this equal, and you can say then c squared is 1. Or negative c squared equal negative 1, which means c squared equal 1. So then you get c equal plus minus square root of 1, which is plus minus 1. But we need c that's in the interval 1/2 to 2. So I'm looking for only c that's in this interval. So you are only going to choose positive value of c. Your answer, such as c that you are looking for by mean value theorem, is positive 1 only, and that's the only your answer. And you're gonna reject the negative 1 part, of course. Let's do a couple more examples. Determine if MVT applies and find all values of C, round to 10,000th place, or explain why it does not apply. Okay, so I have fx equal cosine of x on the closed interval 0 to pi over 2. Cosine function is continuous on all real numbers. Right, so step 1, since f is continuous on all real numbers, it is continuous on closed interval 0 to pi over 2. Second, what is f prime of x? What's the derivative of cosine x? That's a negative sine x. And negative sine x exists for all real numbers. That means f is differentiable on all real numbers. So therefore, it will be differentiable on open interval 0 to pi over 2. So you can say, since f prime exists for all real numbers, f is differentiable on open interval 0 to pi over 2. So then what can you conclude? Thus, mean value theorem applies and there exists a C in the open interval 0 to pi over 2 such that f prime of C equal f of pi over 2 minus f of 0 over pi over 2 subtract 0. Then that's equal to, what's f of pi over 2? Can we calculate on the side? F of pi over 2 is equal to cosine of pi over 2. What's the cosine of pi over 2? That's a 0, right? And what's f of 0? That's a cosine of 0, and it is 1, right? So then this is equal to, go back to where you came from, f prime of c then is equal to f of pi over 2, which is 0, subtract f of 0, which is 1, over pi over 2 subtract 0 is pi over 2. So it is negative 1 over pi over 2, which is equal to negative 1 times 2 over pi. So it is negative 2 over pi. So now you can set that equal to f prime of c, and you found the f prime of c right here. So f prime of c then will be equal to negative sine of c, and set that equal to negative 2 over pi. So negative cancel. You can say sine c equal 2 over pi. How do you solve that? C is then sine inverse of 2 over pi. And they said to give the C value rounded to 10,000th place. So if you use calculator, make sure calculator is in radian mode. And if you do sine inverse of 2 over pi, you get C equal 0.6901, which is in the interval 0 to pi over 2, as a pi over 2 is 3.14 divided by 2, which is bigger than 0.6901. So you just found such a C that is guaranteed by mean value theorem. Last question. Determine whether mean value theorem applies, and if so, find all values of C, or explain why it does not apply. And I'm given f of x equal absolute value of x minus 2 on the interval 0 to 4. You should know the answer already, yes? Okay, but let's do one step at a time, just like how you would do it on the test, if this was on the test. Step 1, what do you say? Is f continuous? Absolute value functions are continuous. This is a famous function who is continuous but not differentiable at a point. So f is continuous on all real number. Thus, it is continuous on closed interval 0 to 4. 2. You know f of x, which is the absolute value of x minus 2, as you know, is what? It is x minus 2 if x is greater than or equal to 2. And it is opposite of x minus 2 if x is less than 2. So f prime of 2 from the left it is less than 2. So you can see the f prime of 2 from the left is negative 1. And f prime of 2 from the right, it's bigger than 2. So the slope of that will be positive 1, which means f prime of 2 does not exist. But the 2 is in the open interval 0 to 4. And since we have an x in the open interval 0 to 4 such that f prime of 2 does not exist, mean value theorem does not apply. Okay, that is everything about mean value theorem. And like I said, mean value theorem is one of the most important theorem in calculus, which means it will be definitely on your next test. So make sure you guys know how to do these problems.